Welcome, students. Today's lesson is called Solving Compound Inequalities. All right, to read the first problem, it says to ride the Mind Eraser roller coaster at Six Flags in Baltimore, Maryland, you must be at least 52 inches tall and your height cannot exceed 72 inches. So what we have is a range. Your height has to be between 52 and 72 inches. So we're going to write an inequality that shows that. So a compound inequality means you have two problems in one. So H is going to represent our height. Your max height is 72. Your minimum height is 52. So you have to be less than or equal to 72, but greater than or equal to 52. And I know that looks like a less than sign, but I'm reading it backwards. I'm reading it from the point of the variable, from H. So I'm saying your height can be greater than or equal to 52 or less than or equal to 72. And then we will proceed with this by graphing it. The way we graph it is we'll put our circle at 52 and we'll shade it in because it has the or equal to. And we'll put our circle at 72 and shade that in because it also can equal to 72. And then it's going to be greater than 52 or less than 72. So that your height has to be somewhere between these two values. This is called an intersection. Whenever they overlap, it's an intersection type of an inequality. All right, let's go on. So now we're going to practice writing compound inequalities for each of these graphs. So when you see an intersection like this where they overlap, you're going to start with your variable in the center. We'll use x. 4 is over here on the right, -1 is over here on the left. It has to be less than, and since it's filled in, equal to 4. And then also greater than, but we're going to write it backwards because we're going from the point of the variable, or equal to -1. And that's your answer. Let's do another intersection. We'll put again the variable in the center, 2 on the right, -3 on the left. It's going to be less than or equal to 2, and then greater than -3, but no equal to because it's a hollow circle. So our variables, remember reading it from the point of the variable. Now this kind of graph is called a union. Not an intersection, but a union. And it's an or graph. So we're going to have the word or in the middle. So if you see a gap or where they don't or overlap, you'll have an or. And then you'll have the right one would be x is greater than -3, no equal to. And then the one over here could also be x is less than -4. You have two problems that you're writing inequalities for, and they're ors. Here's another or situation. X is greater than or equal to 3, or x is less than 0 without an equal to. Let's go down and do another or. X can be greater than or equal to 6, or x can be less than or equal to 3. Those are your two situations. And again, x can be greater than 0, or x can be less than or equal to -3. Let's go to our next section, next set of type of problems you're going to see. You're going to have to solve the compound inequalities. So that means you're going to have two answers. They're either going to be unions or they're going to be intersections. Now this says and, so obviously an and is an intersection. Solve each one first by themselves. So it'd be +3 + 3. 3's cancel. You'll have y is greater than or equal to -8. And then solve this one, +3 + 3. You'll have y is less than or equal to -5. So when you see these two answers, that's what you have to graph. So we'll go down here, we'll put a circle at -8, we'll fill it in. And we know we're going to be going to the right for greater than. We're also going to put a circle at -5 though, and we're also going to fill it in because it's an equal to. And we're going to be going less than. And here's the section where they overlap. This is an intersection. So now the way you express your answer, you'll have y in the center, -5 on the right, -8 on the left. You'll keep your symbol like it is for the -5. Flip this one back around. So it will be, looks like a less than symbol, but you're reading it from the point of the variable. So you're saying y is greater than or equal to -8. And there's your answer. And your graph goes along with it. When you see it like this, you're going to create two separate problems. The first problem, you'll use this part, and you're going to rewrite it over here to the side. 6 less than or equal to r plus 7. The middle part, the r plus 7, will be in both problems. The second problem will have this part in it, and you'll write this over here. R plus 7 less than 10. So if you'll stop and look at this, the middle part, r plus 7, is in both problems. The less than 10 is in one, and then the 6 less than or equal to is on the other side. Now you'll solve each one. Subtract 7, we'll have negative 1 less than or equal to r. Subtract 7, and we will have r is less than 3. There, we're finished. Now we're going to graph these. We've got a negative 1 here, and we will fill it in. We have a positive 3 here, and we will not fill it in. We're going to say r is less than 3, but r is greater than negative 1. And there's our intersection. If you need to flip this around so you know for sure, that's how you know the arrow goes to the right, because r is greater than or equal to negative 1. But we're going to use this one when we write it as our answer. Bring down r is less than 3, and then our less than or equal to negative 1 will go in the front. That's how you express your answer. Let's go to our next problem. Again, we're going to separate it into two problems. Negative 3 less than or equal to 7c plus 4. We're going to do this part. 7c plus 4 is less than 18. And we're going to solve each one. Subtract 4, Negative 7 less than or equal to 7c. We'll divide by 7. Negative 1 less than or equal to c. Write that back, turn it around if you need to know how to graph it. C is greater than or equal to negative 1. Now we're going to solve this one. Subtract 4, 7c is less than 14. Divide by 7. We'll have c is less than 2. Now when we go to graph these, we're going to find our positive 2, put a hollow circle, and we're going to be less than, so we know we're going that way. Then we're going to find our negative 1, which is right here. It's equal to, so you circle, color in the circle, and it's greater than, so we're going that way. As you can see, this is another and, or an intersection. So we're going to rewrite our answer. C is in the center, 2 is here with our less than, negative 1 is over here with our less than or equal to symbol, even though we're saying C is greater than or equal to negative 1. And there's our answer. Our answer has to fall between negative 1 and 2. But it can include negative 1, but not 2. I'm going to show you a couple of ors, and then we're going to be done with this lesson. An or problem like this, you're just going to work out get two separate answers. A plus 1 less than 4, we'll subtract 1. We'll have A is less than 3. Or add 1, and we'll have A is greater than or equal to 4. We'll go down here and graph it. We've got a positive 3, put a circle at. We will not fill it in, and it's going to be less than, so going this way. And the other one is a positive 4. We will fill it in because it's equal to, and the arrow will go to the right. So now you can see that our answer can be less than positive 3 or 4 or greater than. So anything between 3 and just before 4 is not included as a solution to either of these. Let's do that again. So you have x is less than or equal to 9. Well, that one's already done. We don't have to do anything here. Or 2 plus 4x is less than 10. So we solve this one, subtract 2. We get 4x less than 8. Divide by 4. We get x is less than 2. So here's our two scenarios. I'm going to erase this graph. First, I'm going to do my less than 2. Here's my circle, and I know I'm going less than. And then less than or equal to 9. Positive 9. Here it is, and it's filled in. And it's less than or equal to 9 or less than 2. So these overlap over here, but you have to understand that anything bigger than a 2 or bigger, is not a solution to this one, but it would be a solution to that one, unless it goes past 9, then it wouldn't be. Okay, that's a compound inequality lesson. I'll see you in class.